previous section, we discussed limits as our variable approached infinity. But there are many other types of limits. We could take the limit as x or any other variable approaches a number. Let's take a look at what that means. The limit as x approaches a, where a is some number, of f of x seeks the value that the function approaches as our variable x approaches some constant number a. Let's take a look graphically and see what that could possibly mean. The limit as x approaches 2 of f of x is looking for the value that our function, again, the y value, right? Because we're talking about the function value, that our function approaches as x approaches 2. So as x approaches 2, what does our function approach? Well, let's see. As we approach 2, what value does our function approach? Sure looks like it's 5. The function value, remember, is the y value. So let's use the same logic to arrive at the other 4 answers here. As x approaches 1, sure looks like y is going to approach 2. As x approaches 0, sure looks like f of x is approaching 1. As x is approaching negative 1, as x is approaching negative 1, sure looks like the y value is approaching 2. And as x approaches negative 2, sure looks like we're approaching 5. Now, if this seems easy, pretty well is. The function above is x squared plus 1. So let's actually just calculate these. Let's take the f of 2, and we're going to get 2 squared plus 1, which is 5. The f of 1 is 1 squared plus 1, which is 2. The f of 0 is 0 squared plus 1, which is 1. The f of negative 1 is negative 1 squared plus 1, which is 2. And the f of negative 2 is negative 2 squared plus 1, which is 5. Those values match what we found before when we did the limits. Now, if you think about the definition, that we're looking for the value that the function approaches as x approaches some value, that makes perfect logical sense. Because if the function is continuous at x equals a, meaning there's no holes or asymptotes, then the limit as x approaches a should just equal the function value. So all we have to do is simply sub in the value that x is approaching into the function. That'll get us the f of a, whatever that a value is, which we know that as long as the function is continuous is equal to the limit.